Today we are going to talk about scientific notation. This is 8M1, Lesson 9, Scientific Notation, Eureka Math. I will give you some overview, some concepts about scientific notation, building upon Lesson 8, which we did recently, and then maybe give you some homework help. And let's get off and running. Let's move over to our Sketchpaddio and figure out what this is all about, this scientific notation stuff. Okay, so we learned, let's just talk about, Lesson 8. Lesson 8, we learned how to convert numbers from numbers to powers of 10. So we learned, this was about, we could take the number 200 and we learned how to rewrite that as 2 times 10 squared, 10 to the second power. We learned how to write numbers like 0.123, and we learned that that could be expressed as 1.3 times 10 to the negative 1. If you forget how to do this, refer back to Lesson 8. Remembering, of course, some keys, that this negative 1, the negative 1 doesn't mean the number is negative, mean the number does not mean the number is negative. Instead, it means the number is less than 1, right? Because 10 to the negative 1 is 1/10. So 1.23 times 10 to the, there's 1 over 10 is equal to our 0.123. And this right here is something you could have done back in 7th grade math. Okay, so I just wanted to remind us where we came from, and that's going to lead us directly into, I'll just leave all that here. It leads us directly into lesson 9. So that was Lesson 8. Lesson 9, scientific notation, is just building upon what we did before. And scientific notation is a form of numbers. It's a way of representing a number where a means of representing a number where a number must be in form d times 10 to the n, where n is any integer, so that's a negative number, a positive number, or 0 that's whole, right? Not a decimal, not a fraction. And then d, I'm going to write it here, n equals any integer, and d is a number that is greater than or equal to 1 and less than 10. So let's figure out what this means exactly. Let's write some examples out, and let's see if these numbers are in scientific notation. Again, every number is going to have a times 10 in it, a times 10 in it, and then you're going to have numbers with this d and this n, and we need to figure out whether the number is written in scientific notation. So let's look. I'll write 5 numbers down, and you can form your opinion about whether they are in scientific notation or not. That's A. B. This is C. This is D. And each one of these is trying to make a point. So don't worry if you don't get it right. I'd like to see you guess and see if you can get these right. So why don't you just pause and see which of these 5 you think are in exponential notation. So pause, or sorry, in scientific notation. So pause and try, and then we'll come back. Okay, I'm assuming you've come back by now. Let's see. So is this in scientific notation? And the answer is yes. Because we have a number that's between 1 and 10. It can be, well, let me write two more out here just for fun. F is 1 times 10 to the first, and then G will be 10 times 10 to the first. Okay, we'll write those two. Okay, B. Let's see about B. B is also yes. Because we have a number here, 6.0 is between 1 and 10, and then n is any integer. And so -4 is an integer because it is a -4. -4 is integers, just like a 4 is an integer, -4. It's an integer. An integer is any number, -3, -2, -1, 0, 1, 2, 3, ... extending in both directions. So those are integers. So this is yes. Check, check. We can just come down here and we can, put happy cats. Oh, happy pig. No, happy cat. We'll go happy cat, happy cat. 12 times 10 to the 10th is no. This is no. It's because 12 is not 12, because 12 is not between 1 and 10. 12 is greater than 10. So it is not in scientific notation. 7.7 times 10 to the 0. This is yes. You look at it and you say, well, 0 is an integer. And 7.7 is between 0 and 10. E, no. And why not? Why not? Because 0.01. This is too small a number. It is not greater than 1. It is not between 1 and 10. So this is not in scientific notation. Okay, 1 times 10 to the first. Well, what's the rule? D has to be between 1 and 10, and it can be 1 but not 10. Notice if D is 1, it's greater than or equal to 1 and less than 10. So yes, but 10 times 10 to the first, 10, it is not, it can't be 10. It's got to be less than 10. So the answer is no. Okay, so if any of these confuse you and I didn't explain it well, leave me a message, I can answer it. But this is just ways of representing numbers in exponential notation. We'll put a happy cat here because we've learned some good stuff. And we're going to move on to the next. Okay, let's make us a new page here. New page, background here. Just a second while I do something and make us a few extra things that we're going to need. Okay. All right. Back here. Okay, good. So now we're going to, the beginning of the chapter, if you will, looked at defining scientific notation, identifying scientific notation. Now, you learned in the last lesson how to convert numbers into effectively scientific notation. And that's, taking a number like 31268, and you're trying to find the number. Remember how we did this? We found the number that was between here and here. And this was 10 to the 5th, and this was 10 to the 4th. And so we knew that this number here was 3.1268 times 10 to the 4th. And if you forget how we did that, refer to the last lesson. But you're always trying to find the number that's below it, the power of 10 that's just below this number, and then you write this number is a number that is multiplied by that, right? Because this number here is 3.1268 times this number. And you can work that out. If you need to write it out longhand and prove that to yourself, you can reprove that to yourself. But that's the mechanism for converting a number into scientific notation. There are some other shorthand ways of doing it, but here's a sure proof way of doing it. Now we're going to talk about adding numbers in scientific notation. Now scientific notation. Now I'm going to give you kind of the rule on doing it. Now I'll give you some intuition about why it's right, but let's focus on this. Let me just show you an example. Maybe I'll give you the intuition right now. So if I add the number 200 and the number 20, let's put these numbers in scientific notation and see if we can figure out something about them. This number would be 2 times 10 squared. And this number is 2 times 10 to the first. Now, if we were to add these numbers, let's just think about this. So if I'm going to add 2 times 10 to the second and add 2 times 10 to the first, I can't just add these numbers together and get 4 times 10 to the third or something. Can't do that. Can't get 4 times 10 squared. You can't do that. There's no easy way to add these numbers, and you can try and convince yourself of it by goofing around with these numbers a lot and seeing what the answer is. But let's look back at what we know the answer to be. So this number, if we add 220, we know that the answer is 220, and our answer is, in scientific notation, would be 2.2 times 10 to the second power. That's our answer. And you really can't do that using these numbers. So the rule is, now let me just give you the rule. And the rule should make sense after we kind of look at it again for a little bit further. You can add the numbers if the exponents are the same. Okay, so let's pretend we had the number 200 and 300. We'd have 2 times 10 squared, and we'd have the number 3 times 10 squared. Well, now we can actually take these and add them together, and we can get 2 plus 2, we can get 5 times 10 squared. We can prove this a number of ways, but I'm not going to bother you with the proof of that. But we can also see that this is true by just adding the outright numbers. 200 plus 300 is 500, and we know that that is 5 times 10 squared. So again, the rule is that we can add the numbers in scientific notation if and only if and only if the exponents are the same. So let's give that a whirl here. So can we add 2.1 times 10 to the fourth plus 3.3 times 10 to the fourth? And the answer is yes, we can add those directly. We can just say 3.3 times 10 to the fourth and 2.1 times 10 to the fourth is 5.4 times 10 to the fourth. And we could do that because the exponents are the same. These are the same. Now, sometimes, though, you have a problem where the exponents are not the same, like up here. Let's look at, say, 1.2 times 10 to the fourth. Now let's keep it small so we can prove it. And then we're going to add to it 6.0 times 10 squared. Well, we can't add those together. So we can either do one of two things. So if the numbers are don't have same exponent, we convert to standard notation. That's one. Or two, we convert to scientific notation, or we convert to, numbers with same exponents. So let's do it both ways. So way number one, sometimes one way will be easier and sometimes the other way will be easier, and you just got to decide for yourself. So let's do it with method number one. We'll do that in green. So method number one, this will be method one, and then we'll do method two in orange or whatever color this is. So number one says convert to standard notation. So standard notation would say, well, that's 1.2 times 1,000. So this is 1, 2, 0, 0. And then 6 times 10 squared is 600. And you can, I did that really fast in my head. You can take your time to do this in methods we used in chapter 8. So now if you add these down, you get 1,800. And you get 1.8 times 10 to the 3. Again, I did it really fast, but I encourage you to take your time and do that conversion yourself. One way to do it, is to find your decimal here, again, and just go, you had to move that 3 decimals. And so that's 10 to the 3rd. 1, 2, 3, and then it's 1.8. Okay. Method number 2 says we're just going to convert these into numbers with the same exponent. So I'm going to leave this first one. We're going to try and put this second number, we're going to try and put it in a form with 10 to the 3rd. So watch how I do that. So the first one is going to stay 1.2 times 10 to the 3rd. And the second one is going to, now you got to pay attention here. We're going to try and figure out how to make this into 10 to the 3rd. Well, 10 to the 3rd is the same thing as, I can use my laws of exponents. I'm going to break this 10 squared down into a 10 to the negative 1 times 10 to the 3rd. And how do we know that's equal to 10 squared? I'm just breaking this apart. This 10 squared can be represented as 1/10 of 1,000, or just think about it, negative 1 times 10 to the 3rd is, you add the exponents and you get 10 squared, right? Negative 1 plus 3 equals 2. And that's how we add, how we multiply powers. We add the exponents. So convince yourself that 10 squared is 10 to the negative 1 times 10 to the 3. And why did we choose this one to be 10 to the 3? Because we wanted it to match this one. We wanted these to match. So then I found the one here, 10 to the negative 1, that I could multiply by 10 to the 3rd to get it to be 10 squared. Okay. Now I still have my 6.0 times 10 to the negative 1 times 10 cubed. Now realize that that is equal to that, and then this 10 squared is equal to this 10 squared. I'm going to circle it, and then we'll erase it. This is my 10 squared, and this is my 6.0. So those are the same. 6.0 times 10 to the negative 1 times 10 cubed is the same as 6 times 10 squared. Now, I want to keep this 10 cubed because I'm going to want to add these. So now 6.0 times 10 to the negative 1 is equal to, well, that's 6.0 times 1/10 is equal to 0.6 times 10 to the 3rd. I'm doing a lot of work here, but I'm doing it to make things real easy on this last step. So 6.0 times 10 squared is the same thing then by going to this first step, and then this second step is 0.06 times 10 cubed. Now I can add. So I want to add this thing to this thing, and I get 1.2 times 10 to the third plus 0.6 times 10 to the third, and now I can add. And I get 1.8 times 10 to the third. And notice I get the same answer because math is perfect. So you can sometimes, and we're going to do happy cat, spinning happy cat if you followed all of that, because this is really critical. This is the whole essence of adding, how you can add scientific notation numbers. This is the hardest part of the lesson. So if you could follow that, great. We'll do one more example, and then I'm going to go straight on to homework help. Or you know what? We'll go straight to homework help because it'll have the example in it. So remember, there's two ways if you have numbers that don't have the same exponent and you need to add them. You can either convert them to standard notation first, which is sometimes easier, or you can convert the two numbers into two other numbers that have the same exponent. Okay, so let's move on and open the last page. And we're going to go straight to, well, let's do one other thing. Let's just remind ourselves of averaging. This is something we should know how to do, but I'm going to remind ourselves of average of two numbers. Well, if you average the numbers, you add them, and then two, you divide by the number of numbers you are averaging. So the average of 3 and 6 is 3 plus 6. You add them, and then you divide by the number of numbers. Well, there's two numbers. Divided by 2 is equal to 9 over 2 is 4.5. And the average of 1, 6, and 9 is equal to 1 plus 6 plus 9 over, well, there's three numbers, 3. So that's equal to 7 plus 9 is 16 over 3 is 5 1/3. And you know what? We'll just give ourselves some happy cats for remembering how to do that. Okay, now we're going to find the average then. I switch colors because I like to do this often. Average of 3.1 times 10 to the 4th and 3.9 times 10 to the 4th. Well, we're going to do the same thing. We're going to add them and divide by the number of numbers. So let's say we got, 3.1 times 10 to the 4th plus 3.9 times 10 to the 4th. And we have two numbers. So can we add these numbers? Can we add these top two numbers? Yes, we can. We can add them because they have the same exponent. Oops. And so that's 7.0 times 10 to the 4th. So we get 7.0 times 10 to the 4th divided by 2. So we're going to take, cancel, 3.5 times 10 to the 4th. Happy cat. Whoa, look at that. Upside down cat. Whoa. Now let's spin him back, straighten him out. Okay. Now, homework help. We'll just do this on a new page. And this is the section that we call homework helper. So maybe you jump straight here because all you needed was a little bit of homework help, and that's nothing wrong with that. You know, we'll put a butterfly up here, homework help. Pretty cool. All right. So the first thing we need to do is I want to remind you, 1A, how do you take 34,500, you know, and put it in scientific notation? Well, the way I like to do it is I like to find the number that's just below it. Why 7? Because there are 7 zeros. And then you have to find out what times this is equal, what times this equals that. Well, the answer is 3.45 times that, 3.45. 3.45 times 10 million is equal to 34 million. So that is our number. Another way people like to do it is they like to say, well, I know the answer is 3.54 because it's got to be between 0 and 10. Or 1 and 10. And then I go, I have my decimal here and I go, well, 1, 2, 3, 4, 5, 6, 7. So that's times 10 to the 7th because I had to move my decimal 7 times. Either way is fine. Okay, I had to move my decimal 7 times. Similarly, if I wanted to say, you know, 0.065, in this case, I know my number is less than 1, so I'm going to end up with a negative number. And I know my number is going to be 6.5 because it's always between 1 and 10. So my decimal is going to end up here. And I have to move my decimal 2 times. 1, 2 to get there. So I know it's 10 to the negative 2. 6.5 times 10 to the negative 2. That's if we had a negative. Sorry, if we had a number that's less than 1. But notice again, this number is positive, but it's between 0 and 1. Numbers between 0 and 1 have a number times 10 to a negative exponent. Negative exponents do not mean negative numbers. Negative exponents mean the number's less than 1. Okay. I'll say it again, I'm sure, before the end of this unit. Okay, so now I want to, on B, part B, I want to add 2 numbers. And in this case, I want to add these numbers that are really big. 3.3 times 10 to the 24th and 4.0 times 10 to the 23rd. Okay, well, I cannot add them. I can't add unless exponents the same. So I'm gonna leave the big one the way it is, and the little one I'm gonna try and make it times 10 to the 24th. So how can I break this guy up to be something times 10 to the 24th? 10 to the what times 10 to the 24th is going to give me 10 to the 23rd. Well, if you think about it, the answer's got to be -1. -1, because -1 and 24 is equal to 23. So now I have 4.0 times 10 to the -1 times 10 to the 24th is equal to 4.0 times 10 to the 23rd. Now I'm going to regroup these guys and rewrite that. Well, 4.0 times 10 to the -1 is 0.4, right? Because 4.0 times 1/10 is equal to 4 over 10 is equal to 0.4. There's other ways to figure that out, but we get, or 0.4, either one. So 0.4 times 10 to the 24th. Now, can I add these two? Yes, I can add them because they have the same exponent. So let's do the final addition. We'll do it in blue, and we'll go 3.3 times 10 to the 24th over 0.4 times 10 to the 24th. And I get 3.7 times 10 to the 24th. What the heck? Where's my happy cat? Where's my happy cat? Oh, there's my happy cat. Happy cat. Okay, great. So hopefully this was a helpful exercise for you. Hopefully the homework helper was useful and that this is all great stuff. Love teaching you guys. Let me know if there's anything I can help you with. You can leave me messages on YouTube. You can, that's usually the best way to do it. Then those questions will help everyone else out. Sometimes other people will answer the question, but if you ask me a question specifically, I guarantee you I will answer it in a video or directly on the YouTube comment section. So you're welcome. I'm doing my best. Love you guys. Over and out.